square root stretch. So in this case, what happened? A logarithmic or square root stretch, it compresses the higher brightness values with an image and disproportionately expands the darker values. This is called as logarithmic stretch, and it is applied by taking the log value or square root of the original brightness values. Okay, and this is a very interesting one, and this also will be doing in the practical class. Next one is the spatial enhancement technique. When you talk about a spatial enhancement technique, it is the other one is the point operation is basically on operate on each pixels. But this particular thing, when you talk about the spatial enhancement technique, it will modify the pixel values from the surrounding pixels or neighborhood. That's called spatial enhancement technique. And this particular spatial enhancement deals largely with the spatial frequency. When you talk about what is spatial frequency is the difference between the highest and lowest value of the contiguous set of pixels. Okay, and it's also otherwise it's called as the, if you see the number of changes in brightness values per unit distance, that's called definition if you look at it. But otherwise it is the difference between the highest and values of the contiguous set of pixels. So in this case, the spatial enhancement, we'll be trying to use certain filters also in the practical class. I think probably after the image classification, we'll be trying to use the filters. Okay, a low spatial frequency in case of a low spatial frequency image consists of smoothly varying pixel values. But on the other hand, if you see an high spatial frequency image consists of abruptly changing pixel values. That's the difference between low spatial frequency image and high spatial frequency image. Okay, I'll repeat again. When I talk about a low spatial frequency image, it will be having certain smoothly varying pixel values. On the other hand, high spatial frequency will have abruptly changing pixel values. Okay, now there are, as I said in the practical, we'll be using certain spatial filters. Okay, in this spatial filters, spatial frequency, basically it is called as what you call that spatial filtering techniques. These techniques, used to improve the appearance of an image by transforming or changing the pixel values. This image filtering is basically a kind of a process for removing certain image informations to get more details about particular image. So we will try to remove certain image information so that we'll be trying to get the maximum possible. So there are different types of one is the low pass filter, the other one is the high pass filter, the third one is edge detection filter. There are three different types of filters are there. In case of low pass filter, what it does, it is basically it is used to smooth the image. This particular filters will be used to smooth the image display by emphasizing what low frequency details in an image. That's why it's called a low pass filter. On the other hand, the high pass filter, what it does, it will do the opposite. It will be trying to sharpen the linear appearance of an image. When you talk about a sharpen, for example, you have a road feature or a river feature, you try to sharpen it. So you will be in a position to get the information. So how it does it? It will be emphasizing the high frequency details in an image. But on the other hand, if you see low pass filter, it will be emphasizing the low frequency details. That's the thing. And the other type of the spatial filtering technique or image filtering technique is edge detection filter. So this particular edge detection filter is used to sharpen what? The edges around the objects. If you have an object, we'll try to do it. And a lot of filters, where a lot of examples are there, you can go through those things in the practical class also. We'll be trying to do a different type of things, pass filters. Okay, and you can see for yourself that how it is, what kind of the changes. In fact, that is your what do you call that exercise. You need to do that. What kind of difference before applying the filters? What kind of the difference you're finding it? You have to take the screenshot and you have to submit in the practical class also. Now, to repeat, can anyone tell me what is low pass filter?
Sir, low pass filter.
Can anyone?
We are talking about the spatial frequency.
Okay. In that case, what happened? It will try to take up the. It will try to take up the neighborhood pixel values, isn't it?
Yes, sir. Yes, sir.
Okay, if after image classification class, we'll be trying to use the different filters. It will be wonderful. The difference will be so nice. You can see for yourself. And he was rightly talking about what is the meaning of low pass filter and what is the purpose of edge detection filters. Why we wanted to go for edge filters? It has the whatever the edges of the objects will be. What is the purpose of edge filters?
Sir, the edge detection filters are used to improve the edges of the image.
Perfect. So in case of edge detection filters, it will try to delineate the edges and the shapes, it will be more conspicuous. That's why the purpose of edge detection filters. So now, if you see, we'll be trying to talk about, because we talked about the what called that image enhancement, we'll be trying to talk about the transformation part, image transformation. See, image transformation means it is basically we are transforming the image by using certain techniques. Okay, it can be many things. Mathematical treatments can be adopted. By that way, what happened, we will be trying to transform the image. What it does, it is basically this particular image transformation. It involve the manipulation of multiple bands of the data. We have a data when multiple bands, we'll be trying to use those multiple bands, and by using certain mathematical formulas or simple formulas, that we can transform the image, that we can see. And we are doing it because in the practical also we'll be trying to do it. Okay, in this kind of transformation, image transformation exercise, what happens, a raw image which is having multiple bands, we'll be trying to take it, and we'll be going for certain mathematical treatments like addition, subtraction, division. We can do these kind of basic operations, we can mathematical things, we can do it, and we'll be trying to get to we will be trying to get maximum information. That's the basic thing of image transformation. Okay, and there are two important things are there. One is, as I said, about the arithmetic operations like your addition, subtraction, division. This can be done, and the second one is the image fusion. Okay, when you talk about arithmetic operation, even multiplication is also a very important thing. So these are the four important operators we can be using it, and we'll be trying to apply those things, and we'll be getting some good information. Well, let us see how. For instance, the change analysis, we can get to know it. And when you talk about the prerequisite of this particular thing, it should be co-registered one. Okay, so let us see the subtraction function. This subtraction function is used to identify the changes that have occurred between images occurred on different dates. For example, this can be used, this subtraction function can be used for detection purpose also, change detection purpose. And this subtraction function is a very interesting thing, and we can see, because how, for instance, one indices is the NDVI, normalized difference vegetation index, that we normally in agriculture thing we'll be trying to use it. And Acha, what is the meaning of spectral signature?
It's the spectral response of various objects, something absorbing and something reflecting. So it may be a materialistic property. So whatever be the wavelength, it interacts with the particular body, and we are going to get different reflections, right? Either in the form of absorption or say it may be reflected. So we are just reading out those changes and then try to render the spatial resolution, right? We are talking about the spatial.
Okay.
So passive and as well as we have passive and active versions of that, right? Something we are either we are about to pass some energy, or else we are using the natural energy from natural electromagnetic energy from the sun. So that part will interact.
Okay. Now, what you're trying to say is that the electromagnetic radiations try to interact with the objects, earth objects. It can be a plant, or it can be a tree, or anything. It interacts, and by that interaction, whatever certain things can be attenuated, and the reflected one, what the transmitted one will be trying to get in the sense by the senses, and there'll be some kind of the variations, and that will be unique with the objects. That's what you are trying to say?
Yeah, yes, sir. It's all about the albedo. I'm talking about the albedo.
Okay.
Sir, to
What
put
is
it
albedo?
simply,
What is albedo?
how different materials reflect to the light,
Okay.
and within the light, the different spectrum available. So it depends on
Okay.
material to material how the reflectance take place.
Okay, very interesting. See, the purpose of asking this question is that it's very interesting because we in agriculture, I'm from that agriculture background, and it's a very interesting part because by using this, the spectral signatures, we will be in a position to classify even the crops. Okay, crops also we can classify. When, for example, we can classify the crops, the C3 crops, C4 crops, and CAM. The different plants also we can classify. That is the purpose of asking. Tirumal, what's your background?
I'm a civil engineer, sir. I have a MTech degree in environmental and PhD degree in environmental.
Environment. Okay. Suraj?
I teach
Suraj?
some geoinformatics subjects to UG graduates. I'm a professor.
Very good. Very good. Very good. So this particular thing, but still now we are talking about the what you call the correction part. Whatever the images you are getting it's already corrected one only you'll be receiving it because you'll be downloading it because already they're giving it all the IRS data, whatever data you're downloading, it's been corrected. But as far as the image, the transformation is concerned, this is a very important thing because, for example, you said that a particular plant, because the purpose of asking is that we can differentiate the objects. That's fine. The second important thing is that, for example, we'll take example of a plant, whether the particular plant, what is the status of it, whether it has been infected by certain diseases, some pest, or whether it has been affected by drought, and what kind of stresses it is having. How to do it? By going for the spectral analysis, we can get to know whether the particular plant has been affected by what kind of problems. So that is spectral signatures. Because if you see, even if the turgidity, the plant, if you see, if it is affected by drought, the turgidity of the cells, so that will be less. So when the turgidity means what, the water content in the plant, if it is less, what will happen? The what are the radiations, whatever the electromagnetic radiation entering to the plant, the multiple reflections, that will be reduced. And because of that thing, what happened, whatever the transmitted radiations from the particular plant, that will be different from the turgid plants. So that way, what happened, by using these kind of things, we can say that the particular, what will be the health of the plant. So that will be the basis for very important indices that's called as normalized difference vegetation index, that we'll be discussing later on. The same is the case even with the other bodies also. When we talk about, for example, one of my PhD students, she has worked on urban heat island effect, and she has used many kind of indices to understand the land surface temperature, what kind of changes it has occurred. And it is a very interesting thing because that is the basic purpose of this kind of image transformation. By using different indices, we can get to know more information. Okay, so we'll try to go back to our discussion. What I said, I was talking about the arithmetic options like addition, subtraction, multiplication, and the first one is the subtraction, because this subtraction can be used for change detection. Okay, next is for example, multiplication. You want to multiply two image, and then multiply what it exactly we are multiplying. We are multiplying the pixel values from each thing. It will be automatically multiplied. So by using multiplication, that operation, for example, you wanted to we have a real image, and that will be you try to multiply with another image, which is a binary image. Okay, 1 and 0. So in this case, what happened? Binary image will be having 0 and 1 values, and it will be what happened? It will be used as a mask. When these two images are multiplied, the image pixels in the real image that are multiplied by 0 will become 0. Others which will not be which are multiplied by 1, it will be the same. Understood? 0 multiplied by any number is 0. But on the other hand, 1 multiplied by the other number, that will be remaining the same. So in this case, what happened? This simple operation, multiplication operation, that helps us to mask certain objects. If it is multiplied by 0, definitely it will be 0, isn't it? So in this way, this particular operation is used as a mask. That minor image is used as a mask. Now, what a subtraction and multiplication. Now, division. That's called band ratioing, because we wanted to divide the image division. We are doing it. It's basically the popular one, what called band ratioing. Band ratio is an image transformation technique that is applied to enhance the contrast between the features by dividing the dn values, dn for pixel in one particular image band by dn values of pixel in another image. Simple division. This band ratioing technique is basically used. We'll be using it for multispectral images. So many indices, this particular thing has been used. I was just talking about the normalized difference vegetation index. Is a very popular one, and particularly this NDVI, because we are using multiple things. Because we are not only using a division, we will be using the addition operator also, division. Subtraction also. Okay. So what is the formula for the normalized difference vegetation index? Because whatever we discussed, Thirumal and Suraj, whatever we discussed, that forms a basis. Spectral signature form the basis to create this kind of indices. NDVI is equal to NIR minus red upon NIR plus red. NIR means near infrared. So this is a wonderful indices, because from almost 30-40 years we are using it. Okay, this particular NDVI indices. The pigment, if you see in the plant leaves, the chlorophyll, it will be strongly absorbing which one? Chlorophyll. It's green. Well, why the plant is green color? Because of the chlorophyll. It will be trying to absorb in the visible light range. Basically, the electromagnetic range is 0.4 micrometer to 0.7 micrometer, or 400 nanometers to 700 nanometer, because that is basically used for photosynthetic processes, because the chlorophyll A and B will be trying to absorb in certain wavelengths. There's one aspect. The second is that even the cell structure of a plant also, what will happen, it will try to reflect more in the near infrared range. Now the issue is that, okay, it will be reflecting in more in the NIR range, but absorption will be different. I mean, its absorption band will be different. So by using this both techniques, they have created a indices. The same is the case. We can think about building index, because many urban bodies are there. I mean, I'm talking about the urban constructions. So it will be different. Each and every feature will have a different spectral signatures. We'll be trying to capitalize those differences, and we'll be trying to create certain indices. Okay. By this way, what happened? By what is the purpose of creating this NDVI? We can quantify the photosynthetic capacity of a vegetation. We can quantify it. And so that is the most important thing. I said that even within the croplands also, we will be in a position to differentiate the croplands based on the photosynthetic efficiency and based on the photosynthetic system also. Because we know, if a plant is a photosynthetic plant, all our green plants, it can be divided into C3 plant, C4 plant, or CAM plants. C3 means, for example, the rice and the wheat all belongs to that particular category. C4 means, actually, what are C4 plants? Any examples? Any examples? Anyone? Anyone?
Sugarcane. Sugar, pineapple, those which do have more
No.
carbon.
No. Who said pineapple?
Thirumal, sir.
Thirumal. No. Pineapple is a CAM one. Sugarcane, perfect. Pratik. Any other plant?
Cotton.
Come again?
Cotton.
Cotton. Okay.
Maize.
Pakyarajan. Okay. Maize, very good. Maize, sorghum, very good. The purpose of asking this question is that even you understand that crops, we know it, but from an image, we are in a position to categorize the plants. Okay, whether it is a rice or a wheat, and of course we'll be trying to go, or even the temporal analysis. Also, we can get to know that okay, it's a paddy or a wheat or a sorghum or a maize crop or a ragi. We can get to know it. But the main thing is that spectral signatures have been used to identify those things. That's the most important thing. And further, whatever we are doing it, there should be some purpose actually. Okay, say for example, by understanding the spectral signatures of a particular plant, for example, Pakirajan was talking about an important crop, cotton. Okay, by using this particular technique, by using the whatever we have discussed till now, by using this technique, they were in a position to find out way back some 10 or 12 years back. The major problem was there in Maharashtra region. Maharashtra region, biotic stress was there. Biotic means particular pest was affecting it. Particular cotton crop. Particular pest means you will be knowing it, because the most popular one affecting the what do you call that the cotton is American bollworm, or it can be Spodoptera litera. These are two important pests. Major leaf fold, leaf eating things. Anyone from agriculture background? Anyone? Pratik, you're from agriculture. Good. So you'll be knowing it. But the major problem as far as the cotton thing is, the American bollworm, that is called Helicoverpa armigera. Forget about the scientific name. The other one is Spodoptera litera. The point here is that, see how RS and GA, this particular thing has been used. They were in a position to find out the reason why that particular cotton, the belt, even that has been severely affected in Maharashtra region. Okay, by using this particular thing. Okay, so what happened? The benefit is that they will be in a position to assess the damage, crop damage. When they assess the crop damage, and definitely the farmers can be provided with certain incentives. And understood, because nowadays, the major thing what we are talking in the last decade is, what is that? Weather insurance, weather crop insurance. We are talking about the weather-based crop insurance. And what is the important input is given by this. Whatever we discussed till now is the input for the insurance. Okay, so they were in a position to, by using these techniques, they will be in a position to find out the damage, extent of damage, what is the intensity of the damage, and based on that thing, they will be providing what the farmers will be getting the benefits. Now, very interesting thing about the spectral signatures is that, see, we should have the benefit. So we all know, I think I don't know how many of you are from Delhi. So we all know we are facing every time the problem of crop residue burning. Way back some few years back, I have published a paper on crop residue burning in Frontiers in Energy Research. What, by using the GHG, the terminology, I mean, what you call that, IPCC, it's called guidelines, we have quantified the amount of greenhouse gases or other pollutants from crop residue burning. We have quantified it, so that's fine. Now, there are a lot of measures, government laws, and a lot of things have happened. Laws have come into picture, and they've stopped the crop residue burning in Punjab and Haryana. Everything where they were doing it, because by incentives to the farmers, and they'll be having certain technologies. By way of using the technologies, the paddy can be, the straw, they can be composted. But there are a lot of techniques have been done. Still this phenomenon of crop residue burning is happening. Now the question is that how this very interesting how this particular RS has helped. Now one group of scientists from PUSA, Indian Agricultural Research Institute, what they have done is that by using the spectral signatures, they were in a position to find out the fire counts, where it has happened, how many fire counts it is taking place, whether it is reduced, when you look at the trend, whether it is reduced, and which particular government, whether it's a Punjab and Haryana, which one is, even now it has extended to Uttarakhand and Delhi as well. So it's coming forward. Well, if you see, a lot of things are happening. And by using this particular technique, they are in a position to find out the fire counts also, the intensity part. Okay, so that is how this is very important. This particular concept of the RS and GA is very important. And I think one who were talking about Pakya Rajan was talking about the cotton. The same is the case with other things also. For example, very interesting thing, because I just wanted to, I'll take only 1 minute. Very interesting thing. Who said you're from agriculture? Some told me agriculture. I think I forgot. Okay. There's a way of see, in West Bengal there was a problem of, now also there's a big problem of arsenic pollution. Okay, arsenic pollution, because of arsenic, it's a groundwater pollution. We know it. How to use this RSGAs to understand the study the groundwater pollution? It's a big question mark. That was the topic of my one of my PhD topic in JNU. So there, what happened? We were trying to find it out. Then very interesting study was there. Because of this groundwater pollution, arsenic pollution, the crop, particular the paddy crop, the panicle gets, what is it called? Some kind of deformation was there. So what is that? By using spectral signatures, can we, I'm asking this question, can we use, by using the spectral signature of this affected croplands, wherein the panicle, it is getting malformed. So we find out the arsenic pollution problem by using this technique, with this analogy, because the particular, what you call the panicle is affected because of this arsenic pollution. By using this NDVI analysis, can we find it out? Can we find it out?
Yes, sir, we can.
That is the wonderful study in 1998, way back in some 25 years back. It is possible, and so that is the purpose of this particular spectral signatures. So now we have discussed NDVI analysis. NDVI analysis. What is that? NDVI means, what is that NDVI? NIR minus red upon NIR plus red. So that will be seeing.
I have one question. Whether based on the remote sensing technique, can we able to recalculate whether how much amount of arsenic is there in the particular crop, for example, in a particular land? Is it possible, sir? It's a reverse computation. Whether it is possible.
Okay. That you have to quantify it. You have to quantify it, because how to quantify it, that you have to create certain algorithms, because you need to understand. Because, for example, arsenic is somewhere, it is what do you call that? I'll give given a simple example, simple mathematical thing. Okay, for example, I'm from agriculture background. I want to know the yield of a simple thing. I want to know the yield of paddy crop. Y. Okay. Y is equal to A plus BX. Something is there. Some equation is there. X is independent one. There can be X1, X2, X3, so many independent variables are there. Okay. So what we'll be trying to do is that we'll be trying to create an equation. So wherein we'll be trying to find out the independent value, and we'll be trying to calculate the coefficients, and thereafter, if that particular equations, if it is done, if it is what you call it's working, that in that way we can quantify the Y value also. The same is the case with you also, with your we need to find out the independent variables first of all. So if we are in a position to find it out, definitely we can do it. Okay. Intika Ahmad. Yeah, Ahmad, you said something. Ahmad, you said something. Okay, so no problem. Okay, no problem. So we are discussing about NDVI analysis. That is basically we are taking into account the NIR band, red band. Okay, NIR, that value will be taken. Next is image. What happened? Okay. Next is image fusion. This image fusion is basically it's a process of combining relevant information of two or more remotely sensitive images, okay, into a highly informative single image. That's called image fusion. We are fusing the two different images so that we will be trying to get one important thing. Okay. Now, this, there is an pan-chromatic images acquired by the satellite. They have higher spatial resolutions. But on the other hand, if you see the multispectral data, will have the spectral, spectral wise resolution will be much higher, but coarser spatial resolution. Can we merge it? Yes, it's possible. That's called as image fusion techniques. Okay. Now, this is about the, we discussed about the correction part and enhancement and transformation. Okay, these are all the two things we have discussed. Now we'll go for the classification part. Image classification is a very important exercise. If you see that, why we are going for classification? When I talk about the classification, we have discussed the correction part, enhancement techniques also. Why we are going for classification? Why you wanted to classify? What's the purpose of classification? Or in other words, what is classification? When you talk about classification, it is basically a process of assigning spectral classes into an information class. For example, crops into certain category, water into certain category. We'll be trying to classify it so that we'll be trying to assign those particular spectral classes into that particular category. Getting my point? That we'll be taking the image classification class. You can understand. We'll be trying to train that. For example, if it's a water body, we'll be trying to train that particular. We'll be trying to get the information about that spectral information, and we'll be trying to assign that particular thing to a water body. Okay, we'll try to discuss in that practical class also. Now, my question is that why we wanted to go for classification? What is the purpose of classification? Anyone?
I have one question.
Yes, sir. Tell me, sir.
So regarding classification only. So when we
regarding classification, we'll discuss later. But just say to me, what is the purpose of classification? Why we should go for it?
So different types of crops are there. So
to study in a small part. Basic and divided in small parts for study.
Okay. Divide the plants into different categories.
Yes.
Divide
for better understanding.
To categorize and you can classify and understand the topic in basic data. And
suppose we have to spray a pesticide over a particular area, so we can spray over that particular area and do not spray pesticide on the remaining part of the area. If we are talking in terms of agriculture.
Who said, Divyan? Who said this thing?
Yes, sir.
Raj. Raj.
Yes, sir. Yes, sir.
I am happy with your answer, because trust me, this is a very important problem. Actually, we are facing it. Okay, we are facing it particularly in agriculture, because the pesticide pollution. Every one of us know about pesticide pollution. That's perfect. But what happened? We were unable to find out the exact location, what to do, where to apply,
where to spray.
When. So many problems are facing it now. Interestingly, within if you see the last 6-7 years, I think students who have completed, the graduates who have completed from Tamil Nadu Agriculture University, Coimbatore, what they have done, they've kind of started a startup, and they used whatever we discussed now, plus drone technology, and they are applying. Divyanshu, Raj, you understand the same thing they are applying in the fields of Tamil Nadu. For 1 hour, I think they are charging 500 rupees or something like that. By using the drone technology, they are applying where exactly to be applied with the particular pesticide. Understood?
I have also completed my commercial drone pilot license training from Indian Institute of Training, Noida.
Okay, good. And that six boys, very interesting. They are from that what you call TNAU products, TNAU graduates, and I was thinking that, see how interesting. It's simple. Whatever we have studied, it's fine, but practical application is more important.
How to apply?
Yes, and they were very successful now. There are a lot of modifications they have done, and they've done it. And now what happened? You said pesticides, it's perfect. When you see pesticide, the other one is that the recent, if you see, in certain cases, I think someone from Tamil Nadu, Pakirajan is maybe from Tamil Nadu, Thirumal maybe from Tamil Nadu. They can understand in particular district in Coimbatore district in Pollachi region, completely some few years back, boron deficiency was there. Boron deficiency and completely devastated. And now there's a problem in front of you, boron deficiency. Because of boron deficiency, the coconut has been completely, there's a problem in front of you. Now, how can you use RS, the drone technology? How can you use it? That's an application. That is a practical application. No point of leading the theory part. The more important thing is that how you can apply it. So this particular technology was used to apply the boron. So by the way, what happened? The crop got rejuvenated. That's the most important aspect. Actually, it's a very wonderful Divyanshu Raj. And someone was saying that I'm happy with Divyanshu Raj. Someone was saying about the, what do you call that? You can have 1 minute. 1 minute. Yes, ma'am. The ninth, ma'am. Afternoon only I have the Gyan Darshan, madam. Yes, ma'am. 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 Now also I'm in counseling only. Now also I'm in counseling. Yes, ma'am. Now also I'm in counseling session only, ma'am. Counseling only. I'm taking counseling class. Now I'm taking only. I'm in the class only, actually. Okay. No, 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 no. Thank you. Yeah. Yes, ma'am. Yes, ma'am. Yes, ma'am. Yes, ma'am. Thank you. Yes, ma'am. Thank you, ma'am. Thank you. Thank you. Bye. Bye. So, sorry. No, I'm happy to interact with you because from Divyansh, I was giving in another example. One student was talking about that, to want what she was saying that she wanted to put it in some classes so that we'll be trying to get more information. That's what she was trying to say.
Sir, Dr.
Now,
Kamna Bhatnagar here.
yeah,
I
you
said
only
that.
told. Very
I
good,
have,
very
yes,
good,
sir.
very good.
Thank you, sir.
Yeah. Now I'll take Kamna Bhatnagar's the point.
Yes, sir.
Now, my own student was what you call done everything. PhD is completed,
Yes.
and her work is on
Yeah.
urban heat island effect.
I also completed my PhD. Myself,
good, good.
Dr. Kamna Bhatnagar. Yes, sir.
Okay, good. So that my student, what she has done is that environmental science pollution research. She has published a book, paper 5.8 impact factor. Good paper.
Okay.
LUC means land use classification. By using that particular simple classification, she was in a position to say that how land use has changed in 3-4 decades and how that may be responsible for causing urban heat island effect. Very nice, very nice. Now, different classes she has done it. Now, what she is doing, what she said is that can we have question is that whether only urban buildings are responsible, or in other words, how to quantify how urban buildings, how much it has contributed to the increase in land surface temperature. For this thing to happen, she can have what? Instead of having number of classes, she can only quantify, take into account the urban building or non-urban buildings. In that way, what happened? Already what she has done one thing, different classes she has taken and a lot of analysis she has done. Now, by by simple using what you call minimum number of classes, she is in a position to say that where all urban buildings are there and how much it is contributing to LST, means land surface temperature. The other one is that we take into account different things. For example, what do you call that? Number one, community parks. Number two, the water bodies in the community. I'm talking about the urban areas. Wonderful study. One is the community parks, how much that has contributed to reduce the temperature. That's the thing. Second, water body. In and around the neighborhood locations, you'll be finding it, the LST will be different. It's very natural. But here, in this case, what happened by using a simple technique of this kind of whatever we discussed about the what you call the NDV analysis, simple techniques, she was in a position to come out with strong conclusions. So that is the thing we need to take into account. Okay, Kamna, thank you very much. Okay, Divyanshi was asking something.
That is also being used for 3D building reconstruction, like using drones, if we can want.
Yes.
So the practical part of drones is being, like, we are lacking somewhere. Like, we are studying geoinformatics, but lacking in terms of implementing it somewhere.
That I agree with you, because most of the time now we are driven by the theory part, because there's no, see, it's not problem solving, you know,
Okay.
because we have, for example, in front of us, we have a problem, and for that problem, we need to apply the theory part, because we are going the other way around. Okay.
Correct,
So
sir.
without that way, what happened, it will not be helpful actually, because see,
One second. So can you connect me with those guys whom you said your junior were there, who started those startup?
you can they were not juniors, they were not my juniors. My batch is 1991 batch. They cannot, they will be super juniors.
Yeah.
Some 3 decades. No, I'm 91 batch. They are just small kids.
So
okay, yeah,
can you connect me with them?
Yeah, we'll try to do that thing, but they are from Tamil Nadu group. You're from
It's okay, no
place?
problem. I am from Bihar, Jharkhand. No problem.
Okay, good. Okay, that's very interesting. That this is a novelty. This is a novelty, because they have in front of them there was a problem and they try to apply it. That's wonderful thing. Another thing I wanted to say to you, because since you asked for it, and the same drone technology, what they have done is that they are using the RSGAS, and they are using this drone because the resolution, the spatial resolution will be much better. So they are using in this what you call that
Multi-spectral
insurance.
camera.
Yeah, weather insurance, they are using it. Understood? They are using it. Okay, and that part, incidentally, that particular student has also my student who has taken this particular course also. This is what I call that. What we are is also a student only. Some 3-4 years back was a student only. Okay, Krishna Nayak, you said something. Krishna Nayak. Krishna Nayak. Krishna Nayak. Do you have any query? Okay. Somewhere we got to know that the purpose of classification. What is it? We know it, classification, and the purpose is get maximum information. That's the basic thing. Okay, and see what is that? Is that we'll be trying to in case of classification, the principle is that the spectral classes will be trying to create certain spectral classes. What is spectral classes? Spectral classes are group of pixels that are uniform with respect to their brightness values. For example, water, it's a spectral class. Okay, water body. Okay, water body. So in that case, what happened? The pixels will be very much uniform, and they will be put in one class, particular class. Okay. So what it does, a user like us, what we'll be trying to do is that we'll be trying to identify the homogeneous group of pixels. Okay, homogeneous group of pixels having similar values, and we'll try to put them in certain information classes like your water body, agriculture, forest. Forest is another very interesting thing. And we'll be trying to create a kind of a thematic map. Okay, and this is basically what happened when this if it is, for example, this thematic information, if it is extracted by using certain software, GIS softwares, we call it as digital image classification. Okay, this is a very simple thing. We'll be trying to do this, everything, whatever we discuss, we'll be trying to do in the practical class, image classification. Okay. So, Dr. Kamna was also trying to talk about the classes, to put it in a minimum number of classes so that our analysis will be much easier. So there will be many spectral classes will be there, and we'll be trying to create certain unique representation, or in other words, we'll be trying to create homogeneous groups so that the basic thing will be to get the information. most of the information, and further analysis will be much easier. Okay, that is the basic thing.
My work is also on the water body affected by agricultural land uses affected by the water bodies like dams and man-made areas like that water bodies.
Okay, in Delhi.
No, sir, it's in Rajasthan.
Okay, good.
Yes, sir.
Good.
Agricultural land
Try to-
affected by the water body.
Okay, you use RSGS, ma'am.
Yes, sir. Somewhere I uses that, but not too much.
Okay, we'll discuss. Matlab, it will be good one because whatever you're saying, it's a good one. Can be done nicely. Okay. Sure. So now we are talking about the image classification. I just talked about what it is and what are the methods, what are the approaches to classification. One is supervised classification, the other one is non-supervised classification. In supervised classification, it is basically the process of identifying classes within the data with inputs from the users. Okay, that's why it's called as supervised, because we provide the information in the form of the training data. We'll see, because we'll say that this particular group of pixels will belong to water body. We'll we'll provide the information to the software, and that's why it's called as training sets, training data. And based on the training data, the software will classify by itself. That's called. That's why, since we are involved, that's why it's called a supervised classification. On the other hand, automatically also it can be. You can see for yourself also. Automatically also it can, based on the unsupervised. If it's unsupervised, it's automatic one. It is a process of automatic identification of natural groups of structures within a remote sensing data. That's called unsupervised classification. So now, what are the steps? What will be the procedure? We'll be seeing it in practical, but still, the first important step in classification is training. The second one is signature evaluation. The third is decision making. These are the three important steps in classification.
What is signature evaluation, sir?
Yeah, we'll come to it. Don't worry, we'll come to it. And we'll see in the practical, you can see for yourself that how it is done. Okay. First important step is that, what is that? We are training. We need to give the information input to the software that this particular group of pixels can be put it in one class, like water body. Okay. So training is the process of generating spectral signature of each class. Okay, you are trying to create or generate a spectral signature of each class. For example, agriculture. So for that agriculture, what will be the spectral signature you will be creating by training the data sets? Okay, that's why it's called as supervised classification. Okay, for example, that you can see for yourself, because why I'm saying is that you need to provide certain the minimum value and maximum value. And that is the most important training, because you need to do it properly. Otherwise, it will not be properly classified. It will not be properly.
It won't be meaningful. Yes, sir.
Yes, it will not be meaningful, because, for example, water body, you should provide the minimum value and the maximum value. So whatever in that particular that range, that will be classified as a water body. Okay, so that way when you select it, train it also. But training also, you have to be very careful. Okay, then your image classification will be much better. And if it is much better, you'll be going for an error matrix calculation. And that way, what happened, your error also will be much less. That is most important thing, because when you wanted to go for publication, your error should be very less. Error matrix, that is also in the last, I think, 18th practical class, you'll be discussing about error matrix. What are the error matrix, how to calculate the error matrix, how to calculate the coefficient, also Carr coefficient, everything we'll be discussing. Okay, so in this case, what happened, we'll be trying to create certain kind of a envelope, spectral envelope. So minimum value also will be pixel value, maximum kind of an envelope will be there, spectral envelope. So all the things, whatever the pixels falling in that particular range, that will be classified into that particular group, particular class. Sorry. Okay. This what do I discuss about the what do you call the statistical description of the spectral envelope is known as signature. Okay. So whatever the spectral envelope we are having it, that will be in statistical terms that we call as signatures. The training, whatever training we're talking about, it can be what you call, most important thing is that we should understand whatever we are discussing right now, image classification. Before we should have know about that area. That means basically ground truthing is the most important thing. Thereafter classification will come. So by ground truthing, you will be understanding, the area, the information about, about the area, what all about, whether it's a vegetation, a forest area, or a cropland, what kind of crop is there. So all the information you'd have known beforehand. The prior experience is there. Okay, knowledge is also there. So that is most important thing for a supervised classification. Okay, otherwise it will not be good, because on the other hand, unsupervised training, because simple statistical technique, clustering technique will be used for in case of unsupervised classification. But in case of supervised classification, you're training it. You will understand how the boundaries will be there, how the boundary of the tank will be there. So if it is man-made, it will be structured properly. It will be, what you call that, structure will be there. Understood? In case of man-made, what do you call that, water bodies. And if you see it's a natural one, look at the boundaries, shape of it will be different. Okay, that basic things we need to understand, where it is, how, when that kind of information you get it from the topographic map, or else you would have known the area, then you can say that. But so before going for class, yes, please.
Sir,
Yes.
sir, please ask to someone unmute their mute their phone, sorry, microphone.
Okay. Is there any? I think all are unmuted. Muted. I think. Okay. Some problem. No issue. No issue. Today is a working day. No issue. Okay. Now it is done. I think. Okay. So what I was talking about? Water body. If it is a natural, see, there is a certain features that you could relate with your. I think what is it called? Visual image interpretation class also. How you will be interpreting that particular feature. For example, parking lot. How it will be? It will not. It's be properly structured. It's buildings. Buildings. It will be properly structured. If it is a natural one, for example, as I said, even what you call that, rivers. It's very interesting thing is that in certain places, if you see, there will be someone told me today. So if you see the image, it will be completely white. I mean, it completely reflection will be maximum. So that in that particular weather, what kind of information you can gather? You have to know the background. Okay, where that particular location is there, whether it is near the water body. Okay, whether it is, for example, some other phenomenon. For example, if it is a salt pan, for example, reflection will be maximum. Salt pan. Okay. So we have to understand whether what kind of features it can be. Okay, in Gujarat area, you can find the Kutch region, you can find salt pans will be possible. And in down south, in certain regions, we can, because the reflection, for example, regions, if you what you call that, I don't know which place in Tamil Nadu, what is it called? They go for this salt things, no? Which region? Anyone?
Tirupur.
No, Tirupur is Osheri. Tirumal, which region?
Salem.
Toothukudi, sir.
No. Huh?
Toothukudi.
Toothukudi. Okay, Toothukudi. Toothukudi is in coastal location. Yes, they go. So what happens? So you have to understand, ground truthing is most essential. Okay. So for example, if you're talking about in your own location, you know all the information beforehand. You know the information. So that will create better classification will be possible. That's the basic thing. Okay. And that too. Go for 15% ground truthing is essential, because you should not completely depend on the software. We should have a proper data. Input has to be given. Ground truthing is most essential. That's most important thing. Okay. Where I was just talking about the training.
Tamil Nadu basic data.
Yeah. So what example I was talking about, salt pan. Okay, salt pan. That will be different. The spectral signatures will be different. And also, if you see near what I have seen actually near, for example, a river, just adjacent to the rivers, if you see the image, certain regions it will be the reflection will be maximum. It will be white in color. Why? There will be the deposition. The clay deposition or silt deposition will be different. That also has to be taken into account. In certain, just adjacent to the rivers, if you're finding some location, I'm talking about RGB band. So in that particular location, you're finding it some kind of it's red in color. I'm talking about RGB. Okay. So what it means, that particular location, because of
Hello.
the availability of water, vegetation is there. We have to take into these small little things we have to take into account for classification purpose. Okay. So so that this will form the basis for your training thing. You train it, provide
Hello.
input to the, yeah, please, Manoj.
सर ग्राउंड ट्रूथिंग किसके लिए इम्पोर्टेंट है जियो इन्फॉर्मेटिक्स में?
क्या जी? What?
ग्राउंड ट्रूथ जियो इन्फॉर्मेटिक्स में किस चीज के लिए इम्पोर्टेंट है?
सबके लिए. Ground truthing means what? All the field information you're giving it, isn't it? You can, before doing any image classification, you have to go to the field. You have to, at least 15% of the things, locations, you have to know it. You have to find out that. I think one exercise is there in practical also. Ground truthing, it is essential, most important thing. Okay. Some ask me the values. Some of when we were doing it, what happened? We would go to the field. We'll try to get the information, and with all your what you call the GPS and everything, we'll try to get the ground truthing information. Along with that thing, we try to get the arsenic pollution. We take the groundwater sample also, and we'll try thereafter we bring it to the lab, and we'll measure the arsenic content also. That is most important. We'll be trying to figure out the relationship. Okay, that's most important thing, and ground truthing is essentially most important thing. So so that is what is called, we need to have prior information. Okay. The second, what is it called? Next, after training, checking of the spectral signatures for repetitiveness class. Okay. When you say repetitive of the class, because definitely we have created properly, we need to understand that whether that particular thing we discuss, we'll do it on practical thing also. Okay, I'll explain again the geometric connections, how it is and everything. Okay.
Hello.
Yeah, someone is asking something.
Hello.
Yeah.
Manish this.
Come again, sir?
Manish this, sir.
Manish. Okay.
Yes, sir. I have received this link today only.
Okay.
So I have missed last two lectures. So
okay.
What should I do?
No, I think it's recorded things are there. We can. I think Deshmukh sir will be watch it. And what I would suggest is that at least, I mean, personally, what I would suggest is that you could try to have your queries, note it down, so that you can contact them in coming classes, because they'll be coming to the practical session also. You can clarify your doubts. That will be better. Okay.
Sir, I was like following for this lectures for last 2 or 3 months with sir.
Okay.
But I only did this week by today.
Oh.
So I am really excited to attend all the lecture and learn these things about AGIS and remote sensing.
Okay. Yeah, I'm happy to listen from you, and it is good. But basically, what I would suggest is that even a few questions also see before coming to the class. It's better if you go through the materials, because the materials are provided by. I mean, it's not because I'm part of it, I'm saying, but it's a really comprehensive one.
Yes,
Comprehensive
that's the plan, sir.
You
That's
can,
the plan.
yeah, you can get
I
to
will
know.
read and come to the lectures.
Yeah, that will be better part.
Sir,
And
sorry to interrupt, but we have not yet received our reading materials also.
Okay, but sir, I think what you can do is that you can at least you have a link for the EGAN course.
Yes, we have received the PDF. I will share that all the PDF in the group we have created, so everyone can get from.
Yeah, you can get to know it, and it is much easier, and it is very good also, because since
That is
because
less,
I
but
know personally.
we don't want it to read from the e-screen material, but from the like manual book. So that's why I
I
had
think,
a subscribed
sir,
to
I
it.
think soon you'll be getting it because already it has been done. Because there are different steps are there because we have, I mean,
Yes.
checks and balances. You know, the kind of quality we are talking about. If we appreciate the quality aspect, so the different checks are there. So we'll be 3, 4 stages. After that only it will go for printing. Okay.
Okay.
Excuse me, sir. This is
Yeah.
Shilpa Chaudhary.
Yes, ma'am.
I just wanted to know because obviously I missed out on all the sessions that happened before this due to like I saw the emails late. So here it is said that we need to like, is it QGIS that I need to install for the practical, or is it Google Earth, or both? What all softwares do I need to install in my laptop?
I think QGIS will be fine, ma'am.
Okay, I don't need to put Google Earth.
It's it's QGIS is fine. I think in some classes, I think
The Google Earth
LBS
is
is there.
also required, sir. For if she's doing MSc, then Google Earth is also
Yes, I'm
required.
doing MSc. Thank you.
Google is also required.
Acha.
Because here there's two batch. MSc is there, PG promo, PGCGA is also there.
Yes, sir. It seems so. In the...
Yeah. Practical.
And so today the lecture was listed for Professor Neenal Mishra, and I think I have taken that was supposed to be on Sunday, I guess.
Yeah, what happened due to
Yes.
certain reasons, she's having some meeting. That's why I've taken.
No, so I just actually the thing is because I have missed out on the sessions, I really don't know which all topics have been covered, or it is just the first time that this has happened. That's the only concern.
Already it was taken, I think, because whatever classes are there, it is in the listed that will be taken up, ma'am.
All right. Okay, sir. And the submissions, because my study center is Karnal, Haryana, but I stay in Pune. And I'll be visiting Haryana in some time. So, like, can I make the submissions before 16th this month? Because then I won't be going there before my exams.
I'm sorry, I don't know about the
Let me
dates
just
and all.
come in here. Sorry, Dr. Venkat.
Yes.
Yeah, sir.
Participants, learners, please. This is a theory session, and I mentioned initially also that not all the counselors are from the IGNOU, and even from the program team and from other counselors, they may not be in a position to answer your queries regarding to administrative part. So because your assignment, everything has to be submitted at the study center, so please be in touch with them. Though I think those questions can be better addressed by those concerned regional centers and studies.